So hi class. So today I'll be doing geometric probability exercise. So and to do this, you really need to know um, the calculator functions. So let's talk about that right here. All right, the calculator functions. And oops, I don't want that. So let's erase that. And okay, so let's talk about geometric. Right, geometric probability, right? Geometric probability. So you need to first determine, right, that it is geometric. Um, but usually you know that it's geometric. So, like in exercise, you know that you're doing geometric, random variable. You're dealing with geometric. But on the test, they don't tell you. So you need to understand how to find geometric, determine the conditions for geometric random variable. Don't forget it's BITS, right? Binary outcomes. That means either success or failure. I means independence, and if independence is not given, you have to kind of do some logic thinking and use the 10% rule. The 10% rule says that the sample size should not be more than 10% of the population size. And then the T is the trials. The trials are unknown, right? The number of trials is not fixed, as is the probability of success. So you need to first determine not the n, sorry, there's no n involved in geometric. You have to first determine the P, the probability of success, and determine the R, which is the value of success. So now, when they ask you for probability equals to R, right? X equals to R. And then you got to first use the second bars, go to second bars, and then you go to find geomet, and then you have to use PDF, right? It's for equals P. And then you put in the P and you put in the R. And then if they ask you for X less than equals to R, right? Same thing. Go to second vars, okay, and then you go to geomet CDF, and it because it's less than geomet CDF, it actually calculates everything less than. All right, so you do the same thing, P and R. Now P, find the probability that X is less than R. So when it's less than R, it does not include R. So you go to the same thing, second vars, geomet CDF, but your R in this case is been minus subtracted by 1. And then you have another option when you have been asked X is greater than equals to R. And then here you go to second vars, but instead of doing geomet first, you take a 1 first. Because geomet CDF actually calculates less than. But right now you want more than, right? More than or equals to R. So you need to take 1, subtract away geomet CDF, right? And then it's P and then R minus 1, because we are trying to find, because this is included, right? X is greater equals to R. That means R is included here. I want less than. That means I need to find one integer less, one value less. So that's why it's R minus 1. So last one, when they ask you for X is greater than R, so you go to second vars, and same thing, 1 minus geomet CDF, and then with a P, and here it's the R. So write this down, right? Write this down, and we'll pause and write this down, and I'll go to the examples right now. So here, as a part of a customer loyalty program, a restaurant's computer chooses orders at random to receive a free appetizer. Each order has 1 in 18 chance of receiving a free appetizer. Each order is limited to 1 free appetizers. Let X be the number of orders the restaurant fills in a day until they give away the first appetizer. So here you go, right? N is not given. It's obviously geometric, and the probability of success is 1 over 18, right? Each order has a 1 over 18 chance of receiving a free appetizer, so it's 1 over 18. Um, and right here, assume that each order getting the appetizer is independent, so you know all the conditions are satisfied. So they ask you here, find the probability that the restaurant first gives away an appetizer on the sixth order, so equals to 6. So we are using PDF. So second vars, and then you scroll up or down. I prefer to scroll up because it's right here. PDF, right? E. And then the probability of success is 1 divided by 18, right? Because here 1 out of 18. And R is the value that you want, the value of success, which is 6. Well, not value of success, the value of trial, right? The 6 is the trial on the sixth trial. So 6 is your X value. So here, round to the nearest two decimal place is point, right? 0.4. Sweet. Okay, so check this out. In one online store, 8% of the orders are placed by new customers. Let M be the number of orders placed in a day to reach the store's first new customer. There again, see, P is given, right? That's 8%. And here you are doing it, right? N is that you count the number of orders until the first new customers come up. So assume each order's customer status is independent. So this is geometric, right? Find the probability that the first few new customer places the fifth order. So your R is fifth. See, N equals to here, big N equals to 5. It's a bit confusing. Why do they use N here? So never mind. Second vars, and then scroll up to PDF, right? Equals to, because they want exactly 5. So PDF, so here is 0.08, right? The probability of success. And here the value is 5. So round to the nearest 0.06. Two decimal place. Sweet. Good. Right. So if you have any questions, you let me know. I'm doing the next exercise after this. So thank you very much.